Hello viewers, in today's session we are going to discuss some important problems related to a Dirac delta function. So here we have to compute this integral involving the Dirac delta function. So we have 0 to 5 e raised to sine square x and delta of 2x minus pi dx, right? Now see, to integrate or to find the value of this integral, let us first look at this Dirac delta function, right? Here we have delta of 2x minus pi. So what we will do, we'll write delta of 2x minus pi as delta of 2 times x minus pi by 2, right? We'll take 2 common from these two terms. So we have delta of 2 times x minus pi by 2, and here we'll apply an important property of Dirac delta function, which says that if we have delta of ax minus b, then this is equal to 1 over mod of a delta of x minus b over a, right? So here this form is of this form, that is delta 2x minus pi. Here we have delta ax minus b, right? So the value of a is 2. So now this expression is equal to 1 over absolute value of 2, then delta of x minus pi by 2, right? So which can be written as 1 over mod of 2 is simply 1 over 2 and delta of x minus pi by 2, right? So now we can write this expression as 0 to 5, and then we have e raised to sine square x, and here we have half and delta of x minus pi by 2, right? We can take half outside the integral, so we have half 0 to 5 e raised to sine square x and delta of x minus pi by 2 dx, right? Okay, now let us see the limits. So here we have the limits from 0 to 5, and let us see this number. This number is pi by 2. So pi by 2 is approximately equal to 3.14 over 2, that is 1.57, right? And 1.57, it lies between 0 and 5. So here we have 0 and here we have 5, and between 0 and 5 we have the number pi by 2, right? Now according to the definition of Dirac delta function, the Dirac delta function takes the value at only this point, that is x is equal to pi by 2, right? So the spike, it exists only at this point, that is x is equal to pi by 2, and for all other points except x is equal to pi by 2, the delta function is 0, right? So we have the value of the delta function at only this point, right? So let us take this function as f of x, right? And let us take pi by 2 as the point a. So we can now have the integral 0 to 5 f of x delta of x minus a dx, right? So fx is e raised to sine square x and a is pi by 2. Now according to the definition of Dirac delta function, the value of this integral is now equal to the value of this function at this point, right? So we have f of a, and a is pi by 2, so we have half f of pi by 2, and we can now write 1 over 2 f of pi by 2 can be calculated by taking x is equal to pi by 2. So we have e raised to sine square pi by 2, right? And sine pi by 2 is 1, that is sine 90 degrees is 1, so we have 1 square. So we have half times e raised to 1, 1 square is 1, so this is 1 over 2 times e, right? So the value of this integral is 1 over 2 times e, right? And here what we have used, we have used an important property of Dirac delta function, that is integral from minus infinity to positive infinity. And if we have f of x delta of x minus a dx, then this integral is equal to f of a, right? So the value of the function f of x at this point a, and here our point a is pi by 2, and f of x is e raised to sine square x. So now let us consider the second problem. So here we have to compute this integral minus infinity to infinity, log of x square plus 1 and delta of x plus 1, right? Okay, now see, if we again consider this integral, that is minus infinity to plus infinity f of x delta of x minus a dx, then the value of this integral is equal to the value of the function f of x at this point a, right? So we have f of a. So this is the definition of Dirac delta function. And here if we compare this integral with this one, then f of x is log of x square plus 1, right? And x minus a is x plus 1. It means minus a is equal to 1, so a is equal to minus 1, right? And minus 1 lies between minus infinity to infinity. So here we have minus infinity, here we have plus infinity, and this is the point that is x is equal to minus 1, right? Which is a is equal to minus 1. So the Dirac delta function is 0 in the entire number line except at x is equal to minus 1, right? So here the value of the delta function, it exists, that is at x is equal to minus 1, right? So the value of this integral is now simply equal to f of a is minus 1, right? And f of minus 1 can be calculated by taking x is equal to minus 1 in this function. So we have log of minus 1 square plus 1. So we have log of minus 1 square is 1, so we have 1 plus 1, so this is log of 2, right? So the value of this integral is equal to natural log of 2.